Can you solve this velocity time graph? I know you will be interested. So please watch this video to the end and you will see how we solved this problem. You will see the question that gave rise to this problem and you will see the solution to this problem. Welcome to Knowledge Base. In this video, we are going to solve a velocity time graph from a given question and we are going to see how to use that velocity time graph to solve the problem in that question. So let's look at the question. This is the question that gave rise to that graph. It says, a car traveled at a uniform speed of 15 meters per second for 70 seconds. It then accelerates uniformly at 2 meters per second square for 10 seconds and finally comes to rest in 30 seconds by uniform deceleration. Draw the velocity time graph of the motion and calculate the total distance traveled. So we are going to take it gradually. The first thing we want to draw is the velocity time graph, which is a graph of velocity plotted against time. The first statement says a car traveled at a uniform speed of 15 meters per second for 70 seconds. The car didn't start traveling from rest according to the question. It started at a velocity of 15. So our velocity time graph will not start from the origin. Rather, it will start from a point on the vertical axis at 15 meters per second. So this is what the first statement looks like. The car started at a velocity of 15 meters per second, which is BE, at point A, not from the origin, and it does that movement for 70 seconds. Let's continue. It then accelerates uniformly at 2 meters per second square for 10 seconds. At point B, it then accelerates at the rate of 2 meters per second square for 10 seconds. So this is how the graph becomes at point C. And we are told that and finally comes to rest in 30 seconds. It means when it accelerated up to point C, it came to rest in 30 seconds by uniform deceleration. So it decelerates in 30 seconds and it came to rest from point C to point D. So this is the velocity time graph formed, and we are told that we should solve for the distance covered under this velocity time graph. So we are looking for the distance covered by this motion. Looking at this, we know that the distance covered under a velocity time graph is equal to the area under the graph. And this shape is not regular. So because it's not regular, we can't solve it using area of a trapezium or what have you. So we have to solve them in sections. So the first section we want to solve is the area of this rectangle. The area of this rectangle will give us the distance covered between points A and B. So let's call that distance S1. After that, we'll find the area of this trapezium. Let's call that S2 to give us the distance in this area. And finally, we find the area of this triangle to give us the distance covered during deceleration, S3. So by the time we find S1, S2, S3 and add all the values together, we would have found the total area covered, which is equal to the distance covered in the entire journey. So let's start calculating the area. But before we start, let's look at this trapezium EBCF. The parallel sides are BE and FC. We know the value of BE to be 15, but we don't know the value of FC. If BE is 15, it means up to this point on the FC line is also 15. But what about the value from this point to this point? We don't know it. So we don't know the total length, or rather the height FC of this graph. So the first thing we want to do is to get the height FC before we start solving the problem. To do that, we can just create a triangle here by drawing a line across this the trapezium, label this point P and find the distance PC. If we can find the distance PC or CP, we can add it to 15 to give us the total distance here FC, which is the height of this triangle, or the one of the parallel sides of this trapezium. So let's consider triangle BCP. Acceleration is 2, time is 10. If this is 10, then this is 10. So we are just going to look for the velocity CP. So BC, which is the slope of this triangle, is equals to CP all over BP. We are looking for CP, so if we make CP subject of formula, CP is equals to BC times BP. And that is CP will be equals to BC is 2, BC is 2 times BP, BP is 10. Because if this is 10, then this is 10 times 10, and that will give us 20 meters per second. So the velocity during the acceleration is 20 meters per second. So if CP is 20 and PF is 15, because if this is 15, this is also 15, then FC is equals to 20 plus 15, and that will give us 35 meters per second. So we now know that FC is 35. Now that we know that FC is 35, let's start solving for the area. First, we start with the area of rectangle OABE, which is the distance S1. So S1 is simply the length AB times the breadth BE, and that gives us 70 times 15. 70 the length times 15 BE, the height of the rectangle, to give us distance S1 as 1050 meters. Now we are done with the distance S1. Let's calculate the distance S2 of this trapezium. So for trapezium EBCF, the area of the trapezium will be equal to S2, which is distance covered, equals to half the parallel sides EB plus CF or FC times the height BP. If we put the values, S2 will be equals to half EB. EB is 15 plus FC is what we calculated the other time as 35, which is this entire height here, times 10. BP is 10, the height of the trapezium. So if we put this value into the calculator, we have that half times 15 plus 35 is 50 times 10 will give us 250 meters. That is the distance covered during acceleration, S2. And then deceleration, distance S3. It is a triangle, as you can see here. So we can calculate the area of the triangle FCD as the distance S3 equals to half base, the base is FD, times height, the height is FC. So we know that half times 30, FD the base, times 35 the height. And that gives us 525 meters. So that the total distance covered, which is OABCD, will be equal to S1 plus S2 plus S3. And that gives us 1050, the one we calculated previously, plus 250 for S2 plus 525 for S3, to give us 1825 meters. So this is the total distance covered during the journey. I hope you enjoyed this video. If you did and you understood this, then try this. What do you think the deceleration would be? What is the deceleration? Can you calculate the deceleration of this motion here? Please put your answer in the comment section, and thank you very much for watching. Endeavor to like, share, comment on this video, and see you in our next video. Thank you.